Question number 3 says, use z-scores and percentiles to solve the following problems. The birth weights of African lions are normally distributed. The average birth of an African lion is 3.6 pounds, so I always like to just sketch this out. 3.6 pounds with a standard deviation of 0.4 pounds. So that means that from here to here, that would be like 4 and 3.2. Go up another standard deviation, that would be 4.4 and 2.8. Go up one more to cover almost everything, that'd be 4.8 and 2.4, right? So this is the average birth of an African lion and the spread of African lions in general, right? So now, what percent of newborn African lions weigh less than 3 pounds? So for A, we're talking about something that doesn't fall right on one of these standard deviations. We want to know less than 3 pounds.
Tyler Johnson, if you're in the building, could you report to the main lobby, please?
The next question asks about 3.8 pounds, more than 3.8 pounds. So again, that doesn't fall right on the line. That would be up here. And this next question, what percent weigh between 2.7 and 3.7? So these are questions where you have to combine some ideas about and z-scores. So what I'm going to do is I'm going to do problems B and D, and then your job is to do A and C. Okay, so what percent of newborn African lions weigh more than 3.8 pounds? So again, that doesn't fall exactly on a line, but we know it's up here. So it's going to be a little less than 50%. So we should expect that first off. Now, we need to kind of figure out how far over, how many standard deviations. Like if it was 1 standard deviation away, we would have a better idea of that. We would be able to use the empirical rule. But it's not a full standard deviation away, right? It's only, a full standard deviation would be 0.4 away. But we're talking about 3.8. We're only talking about 0.2 away. So we do 3.8 minus 3.6. That equals 0.2, and then we divide by how many standard deviations that is. And we divide by what 1 standard deviation is. So it turns out that it's a half of a standard deviation, right? Or 0.5. So we have moved 0.5 standard deviations over. So now that we know that's the same thing, 1/2 or 0.5, that's the same thing as the z-score. So we need our z-score table now. So we get out our z-score table, and the z-score table is going to give us a percent. So we look here, and we go to the positive side of z-score, and we're looking for 0.50, right? So this is 0.5 is the same thing as 0.50. So you go down 0.5, you go over 0, and this is the percent, but it's not the percent that falls above. It's the percent that falls below, and you should be able to tell that. This is below. 69.15 falls below. We want what falls above. So you need to take 100 minus that. So that's, if I just round to 69, then 100 minus that would be 31%. So the answer to question B is 31%. 31% of newborn African lions weigh more than 3.8 pounds. Now, determine the birth weight of a lion cub in the 80th percentile. That's just moving backwards. We need to find the 80th percentile on this chart, right? So 80th percentile right in here, right? And this is a little bit closer. So we're talking about a z-score of 0.84. So for D, we've got a z-score of 0.84. Okay, now with a z-score of 0.84, that's how many standard deviations you are away. But we need to turn that into actual pounds. 0.4 pounds is a standard deviation, so we just need to work backwards. We need to take this, we need to multiply it. See, remember, we divided by 0.4 over here. We need to multiply it by 0.4, right? So 0.84 times 0.4, that's 0.336. And then that's how far you are away from your mean. That's 3.6. So you need to add that to your mean, just like before we subtracted. So we need to do 0.336 plus 3.6. And that is 3.2. 936. So determine the birth weight of a lion cub in the 80th percentile. So 3.9 pounds is the birth weight in the 80th percentile. So you do A and C.